Hi students, today we will see the fourth topic from your book, that is altitudes and medians of a triangle. Now let us recall. In the previous standard we have learned that the bisectors of angle of a triangle as well as the perpendicular bisectors of its sides are concurrent. Now do you know what is meant by concurrent? If three or more lines passes through a single point, then that lines are known as concurrent lines and the point is known as point of concurrence. Now last year we had seen that the angle bisectors of triangles, they meet in one point and that point is known as the incenter. As well as if you will draw the perpendicular bisectors of sides of the triangle, then they meet each other in one single point and that point is known as the circumcenter of the triangle. Okay, now we'll see the activity. Last year you had done this activity. Draw a line, take a point outside the line, then draw a perpendicular from the point to the line with the help of a set square. That is the revision of last year. Now this year we will study the altitude and median of a triangle. First of all, we will see the altitude of the triangle. Here in your book, they given the triangle ABC and they draw the perpendicular AP on side BC of the triangle. Now, by this, we will make the definition of altitude of a triangle. See here, the perpendicular segment drawn from a vertex of the triangle. Okay, the perpendicular segment. Here AP is the perpendicular segment. Okay, AP is the perpendicular segment. This segment perpendicular from a vertex. Here we draw this AP from vertex A of a triangle on the side opposite to it. Now vertex A's opposite side is side BC. So we had drawn a perpendicular segment from a vertex of a triangle on the opposite side to it is called the altitude of the triangle. So here this AP is the altitude of the triangle. Okay, so segment AP is an altitude on the base BC. Suppose you will draw the perpendicular segment on side AC, then you will see here perpendicular segment 90 degrees angle it will make. Another we will see, if you will draw the perpendicular segment from vertex C on side AB, then they will intersect each other in one point. So these three altitudes are also concurrent. Okay, one more time I will repeat the definition of altitude. That is, see here, the perpendicular segment drawn from a vertex of a triangle on the side opposite to it is called an altitude of the triangle. Okay, a perpendicular segment drawn from a vertex of a triangle on the opposite side to it is called the altitude of that triangle. Okay, now we'll see how to draw the altitude of a triangle. You have to draw this altitude in your notebook according to the procedure given in your book. First of all, first step is you have to draw any triangle. Any triangle means any type of triangle. Acute angle triangle, obtuse angle triangle, right angle triangle. But first of all, they had drawn here the acute angle triangle. Okay. Draw any triangle XYZ means you can take any measure and you have to draw the triangle XYZ. Now draw a perpendicular from vertex X. Look, here they hold the set square and they drew the perpendicular. You can use the protractor also to draw the perpendicular. Okay, this angle it will be exactly 90 degree. Now draw a perpendicular from vertex X on the side YZ using a set square. Name the point where it meets side YZ. Here they had given the name as point R. Segment XR is an altitude on side YZ. Okay. Now next step, considering side XZ as a base, draw an altitude YQ. Okay, here look, you can see in second figure, they drew the altitude YQ on side XZ such that segment YQ is perpendicular to segment XZ. Okay, now next step, consider side XY as a base. Draw an altitude ZP on segment XY. Segment ZP is perpendicular to segment XY. Now, you can see here in the figure that there are three altitudes from each vertex. Look, from vertex X, XR, okay, vertex Y, YQ, and vertex Z, ZP. These are the three altitudes of triangle XYZ and they meet each other in point O. Okay, this point O. So here all the three altitudes of a triangle is concurrent. Okay, the point of concurrence is called here. This point is known as the ortho center. Okay, of the triangle, and this ortho center we are denoting by point O, letter O. Okay, note that the three altitudes are concurrent. Why concurrent? I said you the definition of concurrent lines means here three altitudes they passes through the single point, so these three altitudes are concurrent. Okay, now we will see the next point, the location of orthocenter of a triangle. Now first activity they given, you have to draw the right angle triangle, draw all its altitudes, write the point of concurrence. Now here look, this first it is 90 degree actual, BD is second, and you have to draw the altitude from C. And where will you get the point of concurrence? Is it inside the triangle? Is it outside the triangle? Or is it on the triangle? That you have to see by using all instruments from your compass, and after drawing the figure you will get the idea where the three altitudes will meet in right angle triangle. Same way, activity second they given, that is you have to draw an obtuse angle triangle and all its altitude. Do they intersect each other? You have to see that. Draw the lines containing the altitudes. Observe that these lines are concurrent. And third one, draw the acute angle triangle like first figure we had drawn. Same way you have to draw acute angle triangle. Draw its all altitudes and observe the location of the ortho center. Okay. Now look here. After drawing these, you will get the answers such as, means you have to check your answers. That is, the altitude of a triangle pass through exactly one point that you know. That means they are concurrent. The point of concurrence is called the orthocenter and it is denoted by the letter O. Okay. Now, if you will draw the three altitudes of a right angle triangle, the orthocenter of a right angle triangle is the vertex of the right angle. Means you will get the orthocenter of the right angle triangle is on the right angle triangle only. It is nothing but the vertex, any one vertex of the right angle triangle. Now next, if you will draw the altitudes of obtuse angle triangle, then you will get the orthocenter of obtuse angle triangle is outside the triangle, means it is exterior of the triangle, and the orthocenter of an acute angle triangle, we have seen that in first figure, it is inside the, means it is interior of the triangle. One more time I will repeat this. The orthocenter of a right angle triangle is the vertex of a right angle triangle. Then the orthocenter of an obtuse angle triangle is in the exterior of the triangle, and the orthocenter of an acute angle triangle is in the interior of the triangle. Okay, for today this is enough. Next video we will see about median of the triangle. Till that time you have to draw all the figures and based on altitude from practice set 4.1. Okay, thank you. Bye.